Hello everyone, and welcome to PaperLedge, the podcast that turns cutting-edge research into captivating stories. I'm Ernis, your guide through the often bewildering, yet always fascinating, world of academic papers. Today, we are diving headfirst into a paper from late 2025. Routing Matters in MoE. Scaling Diffusion Transformers with Explicit Routing Guidance. Yes, that's quite a mouthful, but trust me, the insights here are worth the climb. What this paper essentially tackles is how to make AI image generation models bigger and better, specifically diffusion transformers, which you might know from tools like Stable Diffusion. Now, imagine you're an architect designing a colossal digital city. Each building represents an AI model, and inside, tiny workers, we'll call them experts, collaborate to construct stunning visuals. But what if these experts aren't working efficiently? What if they're tripping over each other, doing the same tasks, or completely ignoring certain parts of the image? That's the problem this paper addresses. The core idea is that when you scale up these diffusion models, you often run into bottlenecks. Simply adding more parameters doesn't always translate to better results. It's like adding more lanes to a highway without managing the traffic flow. You just end up with a bigger traffic jam. To solve this, the authors explore a technique called mixture of experts, or MoE. Think of MoE as assigning different specialists to handle different aspects of the image generation process. But here's where it gets interesting. The paper points out a key difference between language and visual data. Language is semantically dense, meaning each word carries a lot of unique information. Visual data, on the other hand, can be spatially redundant. Picture a field of grass, lots of similar-looking blades. This redundancy makes it harder for the experts to specialize effectively. So, the authors propose PROMO, which stands for, well, let's just say it's a clever name. PRO introduces a two-step routing system with explicit guidance to encourage expert specialization. Let's walk through my mental memory palace of PROMO. To really get this to stick, I want you to picture a grand mansion. Each room holds a piece of our puzzle. First, we enter the conditional routing room. Imagine this room filled with sorting machines. This is where the model figures out whether a particular part of the image needs special attention, like, say, adding a specific object or detail based on a text prompt. It divides the image tokens into conditional and unconditional sets. Think of conditional tokens as the parts of the image that depend on the prompt, and unconditional tokens as the parts that are just generally there. Next, we move into the prototypical routing room. This is where the magic really happens. Picture this room as a hall of mirrors, each reflecting a different expert. The conditional tokens now get assigned to experts based on their similarity to learnable prototypes. These prototypes are like ideal representations of what each expert should be focusing on. The experts then refine these assignments based on the semantic content of the image. Now, you might be wondering, why is this routing so important? Well, it's all about efficiency and coherence. By explicitly guiding the routing process, the authors ensure that each expert focuses on a specific type of visual feature, leading to more coherent and high-quality image generation. But wait, there's more. To further enhance this process, the authors introduce a routing contrastive loss. This loss encourages experts to work on similar patterns, enhancing coherence within each expert's domain, while also promoting diversity between experts. It's like training a team where each member knows their role and works in harmony with the others. The results are impressive. The paper demonstrates that PRO outperforms state-of-the-art methods on the ImageNet benchmark, achieving significant gains in image quality and scalability. And get this, PRO achieves these results with fewer activated parameters than other models, which means it's more computationally efficient. Fine, yeah, I guess. Look, the point is, this paper is a big deal. It proposes a novel and effective way to scale up diffusion transformers for image generation by explicitly guiding the routing of visual information to different experts. This approach not only improves image quality but also enhances computational efficiency, paving the way for even more powerful and creative AI models in the future. So, the next time you see an incredibly realistic AI-generated image, remember the unsung heroes working behind the scenes, the routing algorithms that ensure every pixel is perfectly placed. And that's the story of PRO. I hope you enjoyed our journey into the world of scaling diffusion transformers. Until next time, keep exploring, keep questioning, and never stop being curious. This is Ernie, signing off from PaperLedge.